All right. Does it look good?
No, you need to rotate it this way.
Help me out there, Lawrence. Help me out. Line me up.
Close enough.
Close enough?
Yeah.
Good enough for who it's for?
Yeah, depending if you're ready on that board or that board.
Pat, I gotta go. Justin told you he needs to leave a few minutes early.
No, I'm picking up your pizza.
Oh.
Picking up my pizza for luncheon. Okay, I'll see you 11.
Okay, see you 11.
Thank you. Bye.
Bye. All right. So here it is again. Now that we're going to get into the metrics, you have your HCE116 conversion chart here. Is it still recording?
Yeah, you're good.
Okay. That there is the chart that she was talking about, the cheat sheet. I saw some of you guys have already printed this out and have it on your desk. That's good. If you go in there, there it is. This is the actual, you can click on it right there, original file, docx, and you can print that out. That will help you while you're doing your homework to have that with you. Okay. Also, when we do have an in-class exam, you can bring this untainted, clear of any extra answers on it, paper to the in-class exam. Okay. So, yes, I would prefer you guys to put this down in memory, but just remember that. Oh, and one more thing. You see here it says 1 pint equals 500, 1 quart equals 1 liter. Reminder, that's fine if I'm doing I's and O's and looking at like a jug full of urine and saying, that's about a quart or 1 liter. That's fine there. But when I'm doing actual math for meds, you need to use the conversion 1 ounce equals 30 mLs as your base for everything. Because if I did 1 ounce equals 30 mLs, 1 pint would be 480, not 500, and 1 quart would be 960 mLs, not 1 liter. Does that make sense? I mean half a liter and 1 liter respectively. Cool? We all good?
So if we're trying to get quarts to milliliters, then we should convert quarts to ounces and ounces to milliliters.
Or quarts to cups, cups to ounces, ounces to milliliters. Whatever is easiest for you. If you know off the top of your head that I've got a quart and that has 32 ounces, then you're good. But if you don't know that there's 32 ounces, then you can go a quart to 4 cups to 8 ounces. Whatever, you're going to have the same result in the end. Because as long as you know the basic units, you can work your way through a lot of stuff, just using some of that common sense that we all have. So, all right, so I opened this up just prior to coming in here, so you guys have this all available to you, and I'll post these lectures on there. So let's see here. So chapters 6 through 9, we start having fun with the metric system. Okay? The metric system is also known as the International System of Units and is the most precise. That is why we use it for medicine and all of those kinds of things, because it's a better calibrated measurement. System of choice for medications and measurements in healthcare setting. We don't weigh in pounds usually. We usually weigh in kilograms. Our medications usually come in milligrams and grams, not drams and teaspoons and other things like that. Or what's the other one? Grains. Although I do have you do some exchange between grains and milligrams in this class, that is only because that's an extra unit of measure that I can have you guys use for conversion practice. But in the hospital setting, you'll never see grains anymore. Aspirin used to be a very common medication that came in grains, but we no longer measure in grains. Okay, so if you do see grains in Grandma's medicine cabinet from aspirin from 1955, you'll know what it is. Okay. So the best part about metrics is it's all part of the decimal system. Everything is in multiples of 10. Okay. Make sure you understand this right here, that you have 3 basic unit of measure. We have one that will measure weight, one that will measure volume, and one that will measure length. Gram is the one that measures our weight, okay? And then, so you'll see gram on every weight measurement, whether it be kilogram, milligram, microgram, or sometimes we have medications that come in grams. But just make sure you understand that weights are measured with grams, okay? Liters is our volume, and that's what we use for measurements of solutions. So just remember that liters. So you can see milliliter or liters. We don't usually see kiloliters or microliters. We usually only use the two of milliliters or liters. And then meter is the one that we're more comfortable with because we see that in grade school, and that's length. So it's either meter or centimeter or millimeter. Those are the ones that we primarily use for length in the healthcare setting, because kilometer or kilometer is for measuring marathons, not for anything else. So we don't use that in the healthcare setting. So you'll see meters for like a height, and then millimeters and centimeters for like wound measurements and other kind of measurements from a smaller kind. So prefixes, make sure that you memorize these prefixes, okay? And these are the most common: kilo, milli, and micro. And then make sure that you understand that when you say a unit of measure, you have to make sure that you have the right prefix and the right basic unit. So milliliter, make sure that you have both, because if I just wrote milli, that could be one of these three, right? I don't know what milligram, milliliter, millimeter, what are you talking about, right? So make sure that you have, when you're talking about the metric system, both units. Milliliter, millimeter, those kinds of things. She made it, yay! Kilogram, make sure to see we have kilo there, it's 1,000 grams. So we have to make sure that we have both the prefix and the basic unit of measure, okay? Just remember, the abbreviations are the first letter of the word. Make sure that you understand that capitals and lowercase actually matter in the metric system. So gram is G, lowercase g. Meter is lowercase m. Liter is capital L. Okay, very specific. And we use, here we go, speaking Arabic again. Arabic numbers are what we use to express quantity. So I don't want to see any Roman numerals, like for 10 milligrams, I don't want to see XMG. Those don't go together. That is not an acceptable answer. Now, if you see, we'll get to it, I think we mentioned it somewhere else, it's like grains, the apothecary measure. Grains, you're supposed to use Roman numerals. Kind of weird, huh? That's part of the reason we don't use it either, because you can get the Roman numerals messed up. So, if you are to have a metric measurement, it needs to be in Arabic numbers with decimal places, no fractions, and the appropriate basic unit abbreviation. Just remember that your quantity precedes the unit of measure, so you have 2 liters there. Make sure you have a full space between number and abbreviation. That's great. It's very important. That'll help reduce meta errors. But I'm not a huge stickler on that on your homework. So when you're doing your homework, if you don't have the space here, 5 space milligrams, I won't mark you off. But what will I mark you off for?
5.0 milligrams.
5.0. I don't want any trailing zeros.
Where's 0?
And I need a leading 0 if there's no whole number, right? For decimal places. But here, that's great. But I'm not the hugest stickler on that. I would prefer a space, but if there is no space, if you just have 5 mg, I'll take it. And like we were just talking about, use leading 0 before decimal, but eliminate all trailing 0. So 0.4 milligrams, not 0.4 milligrams, and 2 milligrams, not 2.0 milligrams, because those could be a hefty mistake if that decimal point disappears and we overdose our patients. So, do not use cc for ml, okay? You let the automotive industry use cc's, okay? When do we see cc's?
Engine size.
Engine size, right? On my motorcycle, it's 1780, I think, or it's 106 cubic inches. But 1780 cc's. Now, in the medical field, we use milliliters. They are the same when it comes to unit of measure. They both measure volume. One's a cubic centimeter, one's a milliliter. But cc in the medical field could be misread as 00. So we avoid it because 2 mLs is way better than 200 mLs, right? So some syringes, I actually looked at one the other day, some companies will still use cc's. So if you see cc, you know that it's an ml. But when you're writing your answers down and doing your math, for me and for anything else, when you're writing orders and those kind of stuff, you will see mLs is the only acceptable term for unit of volume when it comes to volume. Avoid periods, especially with my handwriting, it could be mistaken as a 1 if written poorly. So make sure that there's no periods. We know that mg is an abbreviation for milligram. We get it. You don't have to prove a point by putting a decimal place. Or a period. So just make sure mg is okay. Place commas and values starting at 1000. So 1,000 is better than 1000. This is another point. I prefer to see commas in your homework, but it will not be points deducted for if it's not there. Okay. Am I blocking my camera or am I good still?
You're good.
Okay, just making sure. My iPad mini that I recorded with last week didn't do the mirror image thing. So I don't know why it did that. I'll have to figure that out. But do not add s's to make things plural, could lead to misinterpretation. So mg is not mgs. We get it. If there's 5,000 in front of it, there's 5,000 mg. We don't need the s to show us that it's plural. We got it. And you might think that I'm crazy and that I'm a stickler and that I'm mean, but I do this because these rules are designed to prevent medication errors, okay? And it makes sure that everybody's on the same page, that we all write the same, we all do things the same, because math is just as much of a language as anything else, okay? So make sure that you understand that. So like we were talking about, gram is our basic unit of weight. That is the only thing we use for weight. Milligrams and micrograms are multiple times smaller than just a gram. So you need to make sure you understand that 1 gram is 1,000 milligrams. 1 gram is 1,000,000 micrograms. Okay. I'll tell you, it's hard for me to remember 1,000,000 micrograms in a gram. So what I do is I put 1 gram is 1,000 milligrams, and 1 milligram is 1,000 micrograms. Okay, that will still help me move the decimal place the right amount of times when we get to that point. But when you start thinking in millions, for some reason my brain doesn't work that good. And when I talk millions, yeah, like Dr. Evil, 1,000,000 micrograms, yeah. So kilogram is the only unit typically used to measure client weight. We don't use pounds. I remember when I first got hired as a nurse, we measured in pounds. That's crazy to me, because now we don't measure anything in pounds. So that's only recent. I've only been a nurse. I've been a nurse 8 years now, but I worked as an LPM first. So I've been working in the medical field for a little over 9 years. And when I first got hired, we measured patients in pounds. So now everything's in kilograms. Okay. Does anybody know why we use kilograms?
It's more accurate.
It's more accurate, but why do we weigh patients?
So you don't overdose them. For medications.
Medications.
Some medications.
Why would I measure a patient every day?
Water
Retention, water gain. So when we have these IV fluids running on these patients for lengths of time, we want to make sure that their kidneys are functioning. We don't want them have them gain excessive pounds of just water weight alone. So we monitor them, and we monitor their I's and O's, meaning their intake and their output, right? And then our weight should coincide with that intake and output. So if I had 1,000 more mLs in than I had out, then I should, this will follow closely, this will make it so that I weigh 1 kilogram more. So 1 liter is 1 kilogram. Does that make sense? 1 liter is 1 kilogram. So I know that if I have this amount I've put in, and I have this amount that I've retained, then I know I can guess my weight is going to be this amount of weight when compared to yesterday. So in the ICU setting, when we watch patients' intake and output, literally to the ml every hour, ml, a lot of times when I work night shift, and our last thing we do on night shift every morning is we calculate the I's and O's for the day, and then we look at the daily weight. And that daily weight that we measure at 5 a.m., most of the time, a good majority of the time, will match the I's and O's. It's kind of cool. So you can kind of like, so when you look at things like, hey, he's weighing this much, but this doesn't match his weight. Where did I miss something? They're like, oh, I dumped that urine at this. Oh, okay, that makes, okay, now, and then you write it in like, oh, now it all matches up. So that's part of the reason why we use kilograms, because they coincide together, and we can monitor I's and O's a lot better that way. So back on track here. We got to convert means to change from one unit to another. So milligrams to micrograms, a lot of this class you will find is all about converting. We're converting from one unit to another unit, right? So the best thing about the metric system is, since everything is based off of decimals, when we want to convert, all we have to do is move the decimals, right? So write this down on the top of everything you do. Big on the left, little on the right, okay? So when you're going from a big unit of measure to a little unit of measure, you're going to move your decimal place which way? To the right. If I want to go from a little unit of measure to a big unit of measure, which way am I going to go with it? To the left, right? Just remember, every test, everything you do, you can even write that on the top of your conversion sheet if you've already printed out. You can write this little monogram, big arrow pointing that way, little arrow pointing that way, to help you remember which way to move the decimal place. So each metric unit in healthcare differs by 1,000 or 3 decimal places. So like I was talking to you before about going, remember we were talking about 1,000,000 versus 1,000 when it comes to those conversions. This is exactly what I was talking about. 1 kilogram equals 1,000 grams. 1 gram is 1,000 milligrams. 1 milligram is 1,000 micrograms, okay? Remember those. 1 liter is 1,000 mLs, all right? And to convert between any of these on the top, all you need is to move the decimal place. And to convert on the bottom, all you need to do is a decimal place, as long as it's within the same unit of basic unit of measure. So if I have mLs and liters, then I can move. But if I have mLs and ounces, then I actually have to do some math. Okay, so they both have to be within the metric system and the same unit of measure. So more back to this example. Big on the left, little on the right. I have 100 mLs, which is little, and I need to move the decimal place to make it a big unit of measure, liters. So which way do I need to go if I'm going from little to big? Little to big. I'm going to move my decimal place to the left, right? So move my 3 decimal places to the left. If you see there, now I have 0.1 liters, and that's how I want it notated. I do not want any just 0.1s. Okay? Another one, 0.75 grams big, and we have milligrams in little. So from big to little, which way do I need to go? I need to move it to the right. So move decimal 3 places to the right. 0.75, 1, 2, 3. Now I have 750 milligrams. Make sure, this happens all the time when we start this chapter, that you change your basic unit of measure. Meaning, when I move that decimal place, I'm changing the prefix. I'm not changing grams, but I'm changing the prefix. So I'm going from grams to milligrams. So my answer needs to be 750 milligrams. I don't want to see 750 grams. We got to remember that if we do one thing on one, we got to do it on the other. So we need to make sure we move. When we move the decimal place, we make sure we change the prefix. Okay? Very common. And especially since we are going through these chapters fast in the beginning, sometimes we forget about some of those basic things. All right, so now that I've given you the good system, I'm going to talk to you about the bad system, or the old system. Not bad, because it's great for cooking. I like when you're baking a cake. You know, we use cups and those kinds of things. We don't measure in mLs when we're baking, or teaspoons. But the old system is the least accurate. Capacities of glasses and utensils may vary by brand, okay, unless it's actually specifically calibrated. But there's really no standard to calibrate. So 1 cup from Pyrex might be different than 1 cup from the Tupperware company, right? Those are both household brand names, if you were wondering. If you go in your mom's cabinet and you look in there, you might find those brand names. Or for some of us that own those things. But anyways, when we are using droppers, those droppers are calibrated to the medication they're using. Okay, so like if I have an ear dropper, I don't take the ear dropper top off that has a dropper and I go, don't use it on my eye drops, right? Because it's calibrated. If it says I need 2 drops of this in my ear every 4 hours, then I use that dropper specifically because it's dose dependent, okay? And the eye drop might be a different kind of drop factor is what they call it. So it could change the actual volume. So if you have a medication that comes with a dropper, make sure that you use that calibrated dropper with that medication. So just remember these. These are the basic unit conversions. 1 teaspoon is 5 mLs. This is on your conversion chart. 1 tablespoon is 15 mLs. 1 cup is 8 ounces, and GTT is equal to a drop. Okay, so those are the usual units of measure that you'll see in comparison. Here's your classic medicine cup that you'll see in a hospital setting, and it looks exactly like this. You have on one side you'll have your ml measurements, and on the left side you'll have your teaspoon measurements or tablespoons, whatever is needed. So just remember, an ounce is equal to 0 OZ. Okay, 1 ounce is 30 mLs, and medicine cups are usually 1 ounce capacity. Okay, and if you notice that 1 ounce is 30 mLs, but what else is it equal to? See here, 2 tablespoons. So sometimes some of your homework will have conversions of tablespoons to mLs and those kinds of things.
But a full tablespoon isn't 15 mLs.
Based off of this, it's close enough. That's why it's what we're talking about. The tablespoons, the household apothecary system is a little bit different. So it's close enough. That's why we use metric though. And just remember, although all these measures may still be on syringes and containers, make sure that you still use the metric system when it comes to ordering and using and doing all that kind of things. So make sure that you understand when we convert within between systems, equivalents are not exact, and that was apparent on that medicine cup when we looked at that previous medicine cup. 2 tablespoons matched up with 30 mLs, but 1 tablespoon was just a little bit different than 15 mLs. Okay, so it's just really roundabout. That's why we switched to the metric system, because it's accurate. So if you see there, we have 1 teaspoon is 5 mLs, 1 tablespoon is 15 mLs. Here's the grains that we were talking about. 15 grains equals 1 gram. 1 grain equals 60 milligrams. 1 ounce is 30. 1 pint is 500, or 16 ounces times 30 would be 480, which is more accurate, like I was mentioning on the conversion chart. 1 quart is 32 ounces, which would be 960 mLs, but they just say for roundabout calculations 1,000 mLs. But I will tell you, I want you guys to use the accurate measurement because we're talking about medications, okay? And 2.2 pounds is 1 kilogram. And just remember, I mentioned it on Web Study, that when you do 1 inch, I want 2.54 centimeters, not just 2.5. Okay, that is the more accurate measurement, 2 decimal places for that. So converting, what is converting? It's when we're changing from one form to another. It's within the same system. We can do that, remember, converting to just by moving the decimal places, or we can do it between systems where we have 2 units of volume. We have ounces and mLs there, and we can go back and forth between those using math. But make sure that results are approximate when you are going between systems. If you're within the same system, it's pretty exact because all we're doing is moving a decimal place, right? But when we're going from one system to another, it's approximate most of the time. So if you Google how many mLs are in an ounce, you will see it's like 29.9436943. It's forever, right? So everybody says 30 mLs. And as long as everybody's using the same conversion factor in the medical field, 30 mLs, then we'll have accurate results. Does that make sense? Okay. So don't go changing anything up. Just use 30 mLs. But make sure you understand memorization is essential. I give you that conversion chart so you guys can start learning, and I let you use it throughout the semester. But I will tell you right now, when you start doing nursing math, if you do the nursing program, it's going to be expected that you have those memorized. You don't get little cheat sheets to use for your stuff. So make sure you understand, memorize those units of measure. Express answers using specific rules related to the system to which conversion is being done. So remember, this is the one that I always stress. No fractions for metric. Always everything in decimals and whole numbers, okay? And make sure you think critically and use appropriate equivalents. In later chapters, we'll start doing what we call dimensional analysis. For those who have taken chemistry, you know what dimensional analysis is. But it's a way of converting units. And so that's where the think critically and using appropriate equivalents will come into play for our math. So when it comes to moving decimals, we mentioned this in the last chapter, we can move the decimals if they're both metric. If we're going from grams to milligrams, liters to milliliters, we can move that decimal. But I can't go from teaspoons to ounces by moving the decimal, right? I can't go from pounds to grains from using just the decimal, okay? So you have to understand that the decimal moving only applies to the metric system. And we talked about the moving into that. So make sure that you understand we can convert using rules, ratio and proportion. When we talked about that, you know, the means and the extremes. It's a way we can use to do some conversions. So you have to state the known equivalents first, okay? And then you can put the incomplete ratio on the other side, okay? So just remember, if you have it milligrams per grain on this, milligrams per grams on this side, it needs to be milligrams per grams on this side. So when you do the means and the extremes, or means and extremes, either way, when you do the outsides and the insides, whatever way works for you, you are multiplying the right numbers to get the right answer. Otherwise, it will mess you up, okay? Make sure that you label all the terms in the proportion when the problem is first set up. That way, when you cancel out, you are left with the appropriate unit, okay? And solve the problem using principles of ratio and proportion. I don't like the means and extremes. I like to put them in fraction form and cross multiply and divide. That is the way that I like to do it. So either way, when you do your homework, if you do means and extremes, or you show your work doing that way, or you do show your work doing the cross multiply and divide method, I don't care. As long as you get the right answer and show your work, we're all happy, okay? Because I do things a little bit different than the book does in my own personal math. So I wouldn't expect you guys to just do it one way and the way I told you to. As long as you get the right answer every way, every time. Final answer for X should be labeled with the correct unit of measure. So now that that sentence has been said, number 5, the sentence has been said. Final answer for X should be labeled with the correct unit of measure. If you have an answer that's not the correct unit of measure, but you have the correct Arabic number in front, you will get half credit. That unit of measure is now important because 50 milligrams is way different than 50 grams, right? So that would be a wrong answer because now that milligram, that gram, that unit of measure is actually telling me where my decimal point is. Okay? So from here on out, from homework starting on chapter 6 through the rest of the semester, if you have the incorrect unit of measure, you will get half credit if you have the right Arabic number. If you have the wrong Arabic number, then it's wrong altogether. But if you have the right number with the wrong unit, you get half credit. Okay? So here's the way of doing ratio and proportion. And we'll do a bunch of these on the board after I'm done with lecture so you guys can have some practice. So we'll just go through it because the lights are off and it's dark and you guys are all nice and cozy and sleeping anyway. So we don't want to wake you yet. So I'm just messing. I see somebody doing this like the heavy head thing. So when I'm flying every once in a while, I have that 10-pound helmet on my head, right? And that heavy head thing never ends well because I'll be flying and then you'll get this. Oh my gosh, I think I broke my neck. But what I did figure out one time, on our old aircraft, because I don't do this. This is bad sleep when you fly, because you got to have eyes out, looking around, making sure that you're safe, because especially around here, we don't have air traffic control. Like when we fly in Tucson, there's a lot of traffic. We have air traffic control saying like, hey, Airback 21, you have a 747 coming in for landing. Make sure you look at your 3 o'clock, and they tell us everything, right? We're always talking on the radio. But here, we don't have that kind of air traffic control, so we always have to keep the eyes out. But occasionally, we were in our old aircraft, there was a pouch behind my head. Well, for night vision that we wear, I have a Velcro on the back of my head that I can put the battery pack on, so we have the official military night vision that we wear at night. And so during the day, though, if I get a little sleepy, I can Velcro that and stick my head to the pouch, and then I wouldn't fall forward, but I could still look around. But if I fell asleep, it'd hold my head up instead of giving me whiplash. Little side note, not really do with math, but try to wake some people up. So 8 milligrams to grams, we know that what we could do is move the decimal place, right? That would be the easiest thing. And which way, let's just talk about this so you know that's not what we're talking about. Which way would we move that decimal if we were going to do just the decimal conversion here?
Left.
Right.
So I'm going from small, little, to big. So I need to the left, right? So I would move it, how many places to the left? 3. So it would be 0.008 grams would be the answer if I was just going to move the decimal place. But doing the means and extremes of the ratio and proportion, 1,000 milligrams to 1 gram is equal to 8 milligrams of X grams, right? We have to make sure that we put our known first, and 1,000 milligrams per gram. If you notice here, what do we have? Milligrams and grams, both, right? So we have to make sure that we have those arranged in the same way. When we do that math, the means and extremes, we come with 1,000x is equal to 8. Doing our normal elementary algebra, that's so hard for some of us to understand. It blows my mind that my 3rd graders are already starting to work on things like this. And it's crazy. I guess they wanted us to be as smart as the rest of the world. So anyways, 1,000x divided by 1,000 divided by 1,000 to get x by itself. With this crossing out, leaving x equals 8 over 1,000. And then we would move the decimal place anyways, right?
So we have to show it that way in our work.
You don't have to. If you, in your homework, I'm showing you this way just because when we start doing other units of measure, this is the way to do it. But for metrics, we can just move that decimal place. And you can even type in there, move my decimal place 3 places to the left, and put the right answer, and I will take that. Okay? But I'm showing you this way because this will come in handy when we do other conversions. So. And this is the way I like to do it. 1,000 milligrams over 1 gram, that's our known. 8 milligrams over X grams, that's our unknown. Doing cross multiply and divide, so 1,000 milligrams times X grams, 1 gram times 8 milligrams, which all comes out honky-dory to get the same answer. I have 0.008 grams. Make sure you have that appropriate unit label. So if it's in the same system, when it's metric, we just talked about this, make sure you move just the decimal place. And make sure that you remember that 1 kilogram is 1,000 grams, 1 gram is 1,000 milligrams, and 1 milligram is 1,000 micrograms. We do the most conversions for this class when it comes to grams and milligrams and micrograms. Those are the most commonly converted groups that we work with. So just remember that. Now, converting between systems, ratio and proportion, so we can use pounds to kilograms. So we know that 1 kilogram, here we go, is equal to 2.2 pounds. So we know that X kilograms is 110 pounds. If we know 3 of the 4, we can do the math, right? So doing the means and extremes, we have 2.2x is 110. And then we divide by 2.2 and divide by 2.2 to get our X equals 50 kilograms. Make sure that that doesn't turn out to be 50 pounds, because 50 pounds is definitely not 50 kilograms. Another common mistake, okay? So make sure you follow what's being asked for. Okay, calculating intake and output. moving on to the next chapter. And I will go through every chapter with some examples on the board after this so we can get some practice. So I'm going to lecture first, and then we'll play on the board. So abbreviated is INO, okay, intake and output. People always say intake and outtake, which is not the same. Intake and output, okay. Used to monitor fluids consumed, injected, excreted. So it includes those pseudo-solids that become liquid at room temperature. So like Jell-O, even though it's a solid when they eat it, the only reason it's a solid is because of that extra ingredient called gelatin that they put in there to make it a solid, but your body uses it as a liquid. So that's why we measure it as a liquid. So if you notice on the Jell-O, a small 4-ounce gelatin will say 120 mLs on it, and that's what we'll monitor for INO. So it's not, when we eat Jell-O, we don't monitor it as a percentage as part of their meal intake like you would when you're a CNA. That actually is measured on their ml intake for liquids. So, it includes, this is the best part, includes liquids that exit the body, diarrhea, urine, vomitus, or emesis, tomato, gastric suction, and chest drainage. Okay. So yes, we do use that. There is some other unmeasurable losses that we can't measure. Does anybody know what that is?
Dehydration.
Well, perspiration is the one that we really can't measure because it's evaporative, right? But we do have some loss there too. But since we can't measure it, we don't do anything about it. But we can understand that we would lose some sweat somewhere and cause some ml loss. But the ones that are easiest to measure because they come out in large quantities at one time is diarrhea, urine, vomitus, gastric suction, and chest drainage. So, may require some sort of conversion, especially in a home health setting where you have family members who are helping take care of it and someone says they need a puke and all they have is a bucket. So you hand them a bucket and they puke in the bucket and they're like, well, how much was there? And they pour it into a quart container and, or their pot. This is a 2-quart pot, so it was about like 1.5 quarts, right? That's all you had to measure, okay? But it does need to be converted to metric, so 1.5 quarts. Remember, we were talking about I's and O's. We can use that 1,000 mLs as a quart. So, but that's the only time when it comes to when we're converting like that.
What exactly would be chest drainage?
Chest drainage is when we have chest tubes. So common with cardiac surgery, gunshot wounds. I had a patient, I stuck a chest tube in a gunshot wound. I had a nasty trauma one time that I stuck a chest tube in him to see. So we do it initially because of symptoms. I can't breathe or something's going on, and then we monitor after that because if I keep having a lot of chest output, then we have to call Dr. Carter to come in and see if he needs to open up to see what's draining, if we have something bleeding that we need to take care of or something like that. Okay, but we do it in cardiac surgery because we've taken this heart, cut it down, and it's in an encapsulated sac, right? Mm-hmm. And it's going to bleed and ooze a little bit because we anticoagulate these patients. But we've done a big surgery, so we're anticipating some drainage, and we don't want that drainage to become a problem. So we'll put them in, that way it can drain off anything so it doesn't become an issue. That's it. So cardiac surgery is the most common that we see the most of where we have chest tube drainage and trauma. So, but we total every 24 hours unless you're in an ICU setting or some other floor that dictates different. On the med-surg floor, they total every 12. But in ICU, we look at our totals every hour. And then we total it to a 12-hour total. And then we'll total that to a 24-hour total. Okay. We used to do it every 8 hours, monitor every 8 hours so we can kind of see some intakes. But we monitor every hour, especially output. Output, we monitor urine output. We monitor the closest every hour. So INO records usually have a key for conversions. 6-ounce coffee cup is like 180 ml. So like when you work on the hospital, when you go in the hospital where the ice machine, the water machine is, and you look at the cabinet above where you fill, like where the CNAs fill up stuff, you'll see that there's that conversion. Because every hospital has a little bit different cup, every hospital has a little bit different spoon, every hospital has a little bit different of everything, right? Based on what manufacturer they got their stuff from. So we have that thing on there. So like 1 cup, 1 jug is like 940 mLs. So we know that when they've drank a whole jug of water that we provide them on admit, we know that they've had about 940 mL, so we can keep track of that better. than just they had one jug, right? That doesn't do me any good. So after conversion, then we add all these items together for total. So if I had a third of a glass of apple juice, one glass was equals 6 ounces, we had 60 mLs there. I had half a cup of coffee, which a cup of coffee is 8 ounces, so it's 120 mLs. And then I had half a pint of milk. 1 pint is 500 mLs, so I knew that I had 250 mLs. Then I would add that all up for 430 mL total, okay? That could be with breakfast, right? So make sure that you use the conversions that are given to you, all right? Because you'll even notice here, even with on the same page, this coffee cup 6 ounces, this coffee cup was 8 ounces. So make sure you use your key. And when I give you work problems like this, I will not leave you hanging. I'll tell you what the conversion factor is. So here's a little example of that. If we worked in a place that still did I's and O's on a written record. Here at Mount Graham, we just recently, in the ICU, we kept track of things on paper and we plug it into the computer, which was double work, but it was really handy because we watch I and O's really close in the ICU, so we could refer to a piece of paper quickly that has all the I's and O's on it, right? But with Obamacare mandating that all medical records need to be electronic by the end of 2015, then we finally said, why are we doing double work? I guess we'll have to learn how to use our computer system better. So we only do it now in the computer. But when we pull it up in the computer, it almost looks identical to this. We'll have a time and what happened underneath that time. So at 8 a.m., I had breakfast and I had 60 mLs of juice, 120 mLs of coffee, and 250 mLs of milk, okay? And it's spelled out like that. More primarily oral intake, IV intake, and other, we'll even specify they had 50 mLs of gentamicin, they had 250 mLs of vancomycin, and medications will give actually specific volumes. Temperature. Remember these temperature conversion formulas, okay? Most facilities are now starting to make that change to Celsius, okay? Here at our hospital, we still use Fahrenheit. Other hospitals I worked at use Fahrenheit. When I worked down at Banner Desert, we were in the process of converting, making sure that all our measurements showed Celsius or centigrade, whatever one you're used to saying. But you need to know how to do this. I've given a report to UMC nurses, and I'll tell them they were like 98.7. I'm like, oh, you mean 37? Yeah, 37, whatever. Centigrade, yeah, cool. So just remember, this is how you do the math. So we have two versions here. We have Celsius to Fahrenheit and Fahrenheit to Celsius. So make sure that you pick the one that has the item you want by itself. So I want to have my answer in Fahrenheit, so I'm going to pick the one that has Fahrenheit by itself and just plug in my numbers and do the math, right? Let's say I need to figure out something from Fahrenheit to Celsius. So I'm going to use the one that has Celsius by itself, and then I can just plug in the numbers I have and do the math. So convert 37.5 to Fahrenheit. So I picked this one here because Fahrenheit is by itself. So then I can just plug in Fahrenheit equals 1.8 times my C, right? 37.5. Do that math first and then add 32 to it. So 67.5 plus 32 gets us 99.5 Fahrenheit. Okay? Same thing here. We have Celsius. I need to convert 68 Fahrenheit to Celsius, okay? So plug it all in. C, 68 minus, see my 68, F, plug that in. That's my Fahrenheit, minus 32, divided 1.8. And guess what? You can use a calculator.
And you have an extra F in that.
I have an extra F in that, yes. But that F means they put that in there. The minus 32 is the minus 32 of Fahrenheit. That is the difference.
Okay.
So it's just a unit label, but don't plug anything in right there. That's just saying that I'm minusing 32 Fahrenheit from the math problem.
Just subtract 32.
So
and ignore the other F.
So yes, so 68 minus 32 divided by 1.8. Make sure you do this math first on your calculator. 68 minus 32 equals divided by 1.8, and you'll get Celsius is equal to 20. 20 degrees Celsius, okay? So metrics measures are used for pupil size, baby head circumference, and wounds and incisions, okay? So when we do big wound vacs, or we have these big open bellies that we have to change the dressings on, in ICU we get out our little sterile, because we want to keep everything sterile. We have these sterile tape measures that we'll use, and we'll put them in there and measure the wound and measure the depth, because we want to monitor healing, that it's not going, getting bigger or getting worse. We want to make sure it's healing and getting smaller, right, these wounds. So we monitor them closely. Baby head circumference, there's some, we want to monitor that because there's some birth defects that baby heads can change, either get bigger or smaller. So we want to make sure that we monitor that so if we can see anything coming up. And pupil size, which is a very common neurological assessment. We do it all the time. If I have really constricted pupils, when I flash a flashlight in there, then I know that I've probably taken a lot of narcotics. Okay, that's pinpoint pupils. If I've had some sort of trauma situation where all my hormones or adrenaline is pumping, what's your pupils do? No matter what the light, they'll be nice and big because they're ready to react. Or if a patient has passed, the iris dilates and relaxes and becomes fixed. So, just some ideas why we use those things. So, we talked about some conversions of weight. Body weight is important in calculating doses for certain medications, especially in the pediatric population. Everything is based off of patient weight. Delivered in milligrams or micrograms per kilogram. You'll see that if you look in your nursing dosing books, you say for like etomidate, it's a medication that we give for induction for surgery. We'll give them 0.3 milligrams per kilogram for their dose. Okay.
And charcoal's 1 gram per kilogram.
What's that?
Charcoal.
Yeah, charcoal's 1 gram per kilogram. That's when you'll see it. So milligrams per kilogram, micrograms per kilogram. IV drips that we do are based off of weight a lot of times. So, like I said, nurses need to calculate safety of doses documented as milligrams per kilogram. So make sure you understand how to do that. And you need to may convert pounds and ounces in pediatric calculations. So a patient might come in and most of the time we'll weigh every patient as they come in, but every once in a while we'll have emergencies come in that the patient's unconscious and has a hard time standing on a scale, right? So we have to kind of guesstimate, the patient looks about 75 pounds. That's what we're used to seeing, right? 75 pounds, 100 pounds. That's what we've been dealing with our whole life, being Americans, because we're in America. But since we're used to that, and then we can because that's what our head uses, then we can convert that to kilograms, right? So just make sure you understand the pounds to kilograms conversion factor of 2.2 equals 1 kilogram. Make sure that you round all answers to the 10th when it comes to those conversions of weight with body weight. So let's do 65 pounds to kilograms, right? We'll do that. I'll continue. Let's keep going and we'll do some of these on the board. I apologize. Pounds and ounces to kilograms. So when we have babies that are born, like I said, when we do pediatric dosage calculations, what do we use? We use kilograms. We don't use pounds and ounces. So we need to convert everything for that reason. So if I'm going to convert 9 pounds 6 ounces or 10 pounds 2 ounces, based on the example on the board here, I need to take my 2 ounces, divide it by 16, and that will give me my pounds now.
It's 0.125.
So 0.125, or I would round that to the 10th, right? So that would be 0.1. So 10 plus 0.1, so actually 10 pounds 2 ounces is 10.1 pounds. Now that I have everything in pounds, now I can do my math at 10.1 times 2.2, or divided by 2.2 gives you 4.59 or 4.6 kilograms, right? So make sure that you, if you have a baby weight, we're doing neonate math, and you have that 10 pound 2 ounce baby or that 6 pound 13 ounce baby or something like that, make sure that you convert those ounces to pounds so that way you can do the 2.2 conversion factor. Kilograms to pounds. 1 kilogram, 2.2 pounds. So if I weigh 24.7 kilograms, if I divided to go one way, I would multiply to go the other. So I'll take 24.7 and multiply that by 2.2 to get 54.34, rounding that to 54.3 pounds. We'll do some of these on the board, I promise. Military time. Welcome to the nursing world. Everything in the medical world is in military time. 24-hour format. We call it international time or computer time. And I'll be honest with you, I never heard the phrase computer time until I read this chapter to teach it. I've always heard international time and military time, but computer time is new to me. I guess I'm not that hip and happening. But they don't have iPad time either, I guess. But computer time uses a 24-hour clock, helps prevent errors by eliminating repetition of numbers. And I've seen a medical error that's occurred because of not using military time in my own career. I didn't do it, but I saw somebody else do it. So, and I'm not lying, but I'll tell you if I make a mistake, because I want you guys to learn from my mistakes so you don't make them. But make sure you understand there's no colon or AM or PM designations. Everything goes from midnight, 0000, and goes for a 24-hour clock to 2400. So midnight is equal to 000 and 2400. It's just depending if you're starting or finishing the day when it comes to math, okay? So 1 a.m., 1 in the morning would be 0100, okay? And here's the clock to show it. So your AM times, we have 01, 02, 03 here, all the way around. Once we hit PM, or 12 o'clock noon, then we go to 1200, and it goes on to 1 p.m. would be 1300, 2 would be 1400. All you have to do is just add, if the PM's, just add 12 to it. So if it's 1 p.m., add 12, and you have 1300, okay? So if I'm going to convert an AM time, all I have to do is get rid of my colon here and put a 0 in front, and look at that, 0845. To convert to PM time, take out the colon and add 1200 to it, like I just said. So 7 plus 12 is 19, so 1950, okay? Well, what's funny is at home, me and my wife are nurses, and I work on a 24-hour clock because I work AirVac, which I do 24-hour shifts, so we fly all night sometimes. I also work ICU, where when I work ICU, I primarily work night shifts. So our clock, when we keep track of things, is based on the 24-hour clock. So when you look at our calendar and you look on there and you look at appointments, Taz has a doctor's appointment at 1300, Tally has a dentist appointment at 1400. That's how we write it on our calendar. So one day we were sitting there at home and her sister was over doing something, and she walked by our calendar and she's like, "Oh, what are all these numbers all over this, And because all she saw was the 24-hour format and no colon and no AM designation. So she was like, why do you have these 4-digit numbers all over your clocks, all over your calendar? And so here you had to explain to her military time. She's like, you guys are weird. But both of us are nurses, so it's what we're used to. And our kids, our home clocks, some of our home clocks are set that way, are set in military time. I put my iPad's in military time, my phone's in military time, and it's just easier because I'm up sometimes 24 hours a day, so my 1 o'clock might be different than your 1 o'clock, right? So I have to keep track of that. To convert times between AM, we were talking about that. Any questions about that stuff so far? Let's do some of these on the board. Let's turn on the lights. Everybody wake up a little bit. Gabrielle, right? Mm-hmm. I'm unchecking you. You made it. Okay. Okay. Open chapter 6 here. We'll pick some out. Okay. Am I on my camera here? Should I move a little bit? Tell me where to move.
You're good.
Okay.
I just wanted to move it down a little bit.
So if I had 300 milligrams, and I want that in grams, What do I need to do?
Move it to the left.
I need to move it to the left because I'm going from small to big, right? Milligram is smaller than a gram. How many places am I moving it?
Three.
Right? Let's do another one. Micrograms to milligrams. Uh-oh.
Move it to the left again.
Because micro is smaller than milli, right?
Right.
How many places? 3, right?
Three.
Because remember,
1,000.
we're doing it by 1,000. There's 3 zeros in 1,000. So I get 1, 2, 3.
Yes.
Is that right?
No.
No. Like the 0 wrong.
And labeled.
No?
Wrong.
Milligram.
Okay. 0.18 milligrams, right? Okay. So I missed my. I'm going from small to big. So how many places?
Three. Wrong.
No.
Still wrong.
I just don't know. Oh, did I do that?
Yeah.
Okay. I go, what? Did I do something wrong? Okay, 3.25 liters. Is this the same as this?
No.
No.
No, because in the room in the metric, that's a different.
That's a mega.
It's mega, right?
Right.
So make sure that you use lowercase m's, lowercase k's, lowercase mcg's, whatever. Make sure that you use the right letter so that you do it right. Okay? One more. So I can move the decimal place. What's the other way we can do it?
Dimensional analysis.
Dimensional analysis or the ratio and proportions, right? We'll do that with the next chapter. So chapter 7, let's do some practice.
Just answer.
We could just answer that really.
15.
That's 15 mLs because we know 30 mLs is a whole. But what could we do to figure this out?
Google.
Other than Google. That's like everything. Okay, Google. Tells you. Especially now, they don't have to push a button anymore. You can just ask the phone and the phone tells you, or Siri. Hey Siri.
That's crazy.
Have you guys seen that movie what's it called, Her? And it's with Joaquin Phoenix, and he falls in love with Siri. Or an equivalent of Siri. I heard it's good. I haven't seen it.
She's a computer.
Mhm. So, anyways.
I have it all on it too.
So what could I do here?
Look at a conversion chart.
Other than looking at, okay, so I look at a conversion chart, and my conversion chart tells me that I have 30 mLs,
Is 1 ounce.
1 ounce.
Okay, so do X equals 1/2 ounce. They're X.
I would, if it was me, I would do this for the math purpose.
Right.
Right, means and extremes.
Yeah,
So that puts me at
15.
right. X is already by itself, so we don't have to worry about this business. Thinking 30 times 0.5. Okay.
15 mLs.
Yes, sir. Not a boy. Okay.
So can we use dimensional analysis of their?
If you have that, do it already. If you got it down, make it happen. I don't care. That's fine. Because we'll get to a chapter where we do, I think it's 16, and we do problem after problem after problem after problem after problem, and then some more problems using dimensional analysis. So if you know it already, start practicing it, because that is about the only way that we can solve some of the problems in the later chapters. Do you want to do another one of those? Mm-hmm. Let's do it. Well, we know that, but let's do the math.
Okay.
1 cup equals 8 ounces.
Can we do that?
Yes.
We're gonna do that conversion first.
We're going to do that conversion first.
Sure.
So 1 cup equals 8 ounces. Okay.
And then it's 30 ounces equals an ml, so how many times does 8 go into 30?
So we have to do this conversion first. 8 ounces is 1 cup. So then we would rewrite the problem. 8 ounces equals how many mLs?
Correct.
Now we have something we can work with, right, using our conversion vector. So now we have 8 ounces. Well, we have to do the known first, right? 1 ounce. I'm going to do the fraction form because I did that. Is 30 mLs equals 8 ounces over X mLs. Okay? Ounces on top, mLs on bottom, ounces on top, mLs on bottom. We are ready to do some math. Cross multiply and divide. So 30 times 8, well, let me do that so we don't get the X mixed up, equals X. Okay. So 240 mLs, okay? So make sure that you understand that sometimes you'll have to do conversion before you do a conversion, based on what you know for your conversion factors, okay? And if you have an easier way that you do it, that's fine, use it. As long as you do it the same way and get the right answer every time. Okay. So, I really like, some of you had me last semester know this, I really like lifting, doing the Olympic lifts. And so, the international unit of measure is in metric, right? We don't measure pounds everywhere else. So when you compete, you use kilograms, okay? So I know my best clean and jerk is 253 pounds, okay? But I'm going to a competition and all we use is kilos. So I have no idea what kilo weight I need to put on my bar, right? Because I'm doing everything, because I'm American, we live in America, I'm doing everything in pounds. So I need it to be in kilos for the competition so I don't mess up and embarrass myself because I loaded it wrong, right? So I need to know how many kilograms.
divided by 2.2.
Easiest way would be, and if you do it this way, you don't have to do the whole means and extremes. If you just put on there 253 divided by 2.2, I will be happy with that.
115.
115, right?
Yeah.
115 kilograms. Okay. Make sense? So I've been practicing a lot doing snatch, and I bought me some snatches on Olympic lift. No judgments, okay? Snatches. Snatches Olympic lift. Okay. Goodness, I'm getting horrible. And that's when it goes from ground to overhead in one movement. And I actually did the other day. This is a true story. I actually PR'd, or got a personal record, and I've been practicing with my kilo weights, and I got a 95 kilogram snatch. Okay, but I'm working out at a gym that doesn't have kilo plates, right? So I need to convert this to pounds.
So multiply by 2.2.
So I multiply, right?
Yeah.
Yeah.
209.
So is it exactly 209?
Exactly.
Yeah, exactly.
I didn't even know. I just 209 pounds. So when I'm working out at the other gym, if I'm going to try that again, I need to load 209 pounds on the bar.
Or load up 205 or 210.
Yeah.
If they don't have.
Yeah, if they don't have single pound weights.
That's unbelievable.
Okay. So I have two beautiful daughters. I don't know if you guys know that. I might be a little bit partial because they are my daughters, but I think they're beautiful. And my first girl was 6 pounds, 10 ounces.
Oh, I hate.
And I swear, if you looked at the picture, you'd notice that it was all on her face. Bless her heart. Oh my gosh, her cheeks were so. Maybe it's because she had the cord wrapped and that we had been pushing all day. So made her face fat. But either way, she was an emergency C-section. The first picture, when they pulled her out, like she's all cheeks. She couldn't even open her eyes. It just. Anyway, 6 pounds, 10 ounces. We wanted to give her a medication when she was born to help because my wife had a little bit of narcotics during the labor delivery process. So we want to make sure that the baby wasn't too sleepy. So we needed to know how much the patient weighed in kilograms. So what do I need to do?
Change 10 ounces to pounds.
So I need to change it all to pounds. I can't do the 2.2 conversion, right? I can't change it from 2.2 pounds to kilos until I have all pounds. So how do I change that?
Put 10 ounces over 16.
6, right? What's 10 divided by 16?
0.625.
0.625?
Yeah.
So 6.625 is now. But we want to round that to the nearest tenth.
6.
6.6 pounds. Okay. Am I still recording? Looks like it.
You're at 1 minute and 8. Yeah, so you're good. Still going.
Good.
So not change
Or an
it to
hour.
kilograms.
An hour.
Okay. Now I need to change that to kilograms. So what do I need to do?
3.
3 kilograms.
And that's what the urge is gonna do.
So that's my first beautiful daughter. The second one was a planned C-section, but she had a heart problem that when she was 18 months old, we had to get a heart surgery. Okay, so we got admitted to the PICU, and we had to do all kinds of drips after the surgery. So they had to know her weight, and I think she was undersized. That was part of the reason how we found out she had the heart defect, because she wasn't getting enough growth in that belly to help when she ate nutrients. She wasn't growing from them. So she was like 12 pounds.
For 18 months.
Something like that. I can't remember.
Wow, that's
She was
small.
small. We just thought she was petite. But she wasn't petite. She was just malnourished. So, 12 pounds is how many kilos?
6.4.
About 19.2. You multiply.
So what's that equal?
5.45 continued.
4 or 5 continued. That's not a good answer though for us, right?
No.
So what is it?
5.5 kilograms.
Okay, so one time I was home and I was laying in bed. True story, I'm not making this up. And I thought I was having chest pain. I'm like, holy hell. And I'm a nurse, you know, a new nurse, so of course I'm paranoid. I'm like, now it's radiating down my left arm. So I'm 27 years old. What is the chances I'm having a heart attack?
Not very likely.
Now, when you're feeling those symptoms, right, you're like, I'm about to die right now. So I'm laying in bed and I tell my wife, I'm like, hey, I think I'm gonna have to go to the hospital. So I go to the hospital and they measure my temperature and I had a racing heart rate, which was normal for my temperature. My temperature initially, when I presented that night, was 102.3. What is that in Celsius? So what do I need to do?
Subtract 32
I
divided
need
by
to use,
1.8.
let's use the formula. So I got the formula. Which one do I want? The one that has the F in the front and the one with the C in the front? C. Okay, what's my formula? Fahrenheit.
Temperature
102.3.
Temperature minus 32 divided by 1.8. 39.5.
So let's do this first. 102.3 minus 32. Anyone?
I already got to the answers.
Well, tell me 102.3 minus 32.
70.3.
70.3 over 1.8, which is
39.05.
39.05. We don't read, so it'd be 31.1
degrees Celsius.
degrees Celsius, okay? So, I went in, and they're like, oh, you have an infection of some kind. So we're gonna give you a broad spectrum antibiotic, fill this prescription, hope you feel better the next day, right? So I wasn't having a heart attack, I just had some fever of unknown origin, so some sort of infection. So, the next day, I actually feel like I'm sick this time. Instead of having chest pain, I actually felt like I was gonna die. So, my fever, I was taking Tylenol and ibuprofen like it was candy. And my fever kept climbing and climbing and climbing and climbing. So, when my wife found me walking around the house, disoriented and seeing stuff, she's like, what is your temperature? Well, I guess I was like beet red, okay? So my temperature was 105.7.
Holy crap.
I was what we call BS crazy.
Yeah.
I was like, it was like, and my wife's a nurse too, so it's like, what's happening here? You're crazy. She's all emotional. I remember that part. No, I didn't hallucinate that. So, I needed to convert this to Celsius. So what is that?
73.7 when subtracted from 32.
40 minus
32.
32.
Right?
Right?
Mhm.
Right. Which equals 40.9.
What's that?
73.7.
40.9.
I didn't divide by 1.8.
Oh.
Okay. So that's how hot I got. If you look on page 111 in your book, it gives you some kind of ideas of where hypothermia, fever, and death occur. So
And he was on almost cooked bread.
I was cooking my brain then. Yeah.
What
So needless to say, they admitted me to the hospital, And I stayed in the hospital for like 6 days getting IV antibiotics. They never found where the infection came from. But what had happened is I got what they call septic, and the infection got into my bloodstream, and it was no longer in one place, it was everywhere. So, anyways, yeah. I don't remember the first 2 days really. I do remember they were giving me tons of fluid, so I was peeing a ton because my kidneys were working just fine. So I was peeing like a racehorse, and I kept telling them, like, I'm filling like 2 of these containers up at a time. I'm like, oh, it's okay. Finally, I told him, like, hey, the doc came in, I'm like, oh, dude, I'm filling up 2 of these at a time, like every 2 hours. He's like, what? So they decreased my fluid amount, but I was getting like 500 an hour for like 2 days. They couldn't figure out what was going on. Gained like 10 pounds. I was like the Stay Puft Marshmallow Man.
Do you remember what you hallucinated?
What's that?
Do you remember what you hallucinated? Because I had the same thing, and I like even remember what I.
See, I don't remember that. My wife said I was just saying funny things and pointing at things and staring at things, and she put me in the tub, you know, in a cool bath in the tub, and I was like shivering to death, you know. So, but the funny thing is, I was talking to a physician like a week prior, and he had those biorhythm charts, you know, where you're going to have your peak physically and your peak emotionally or whatever, health-wise, you know. Anyways, like a week prior, he's like, we were playing with it on his phone. He had an app because I have an app for that, and he said, he's like, oh man, in 1 week you're going to have a shitty week. I'm like, really? He's like, yeah, it's right here. It says you're gonna be pretty bad off. I'm like, whatever. So guess who was my doc the day I came in with the 105/710?
That same doctor.
I'm like, ooh, you did this to me. You called it out on your biorhythm chart because it was like almost to the day. I go in and I'm a mess. So everybody in the ER thought I was gonna die.
You should.
I mean that's why you don't tell people. Results that they're not supposed to know. It's not out of your scope of practice. Because I guess they got the slides back pretty quick saying that I had something growing. And so the tech, out of all people, comes in and was like, oh my gosh, it's the most horrible thing ever. You're going to die. The tech, not even my nurse or the doc, it's the tech comes in. Let's do one more thing. What time is 13:57 in normal time?
1:57.
Yeah.
PM, right? Your homework's due on March 13th at 11:59 p.m. What time is that on military time?
23:59.
23:59. Do I put a PM?
No.
Yeah. I opened up your module today so you could study at 8 a.m., right? Before class. Oh, I almost gave you the answer off the bat. 8 a.m.
Oh, 8. 0.
Is that right? No, thank you. Just 0800. Okay.
You could put an AM on there if you want to get it wrong.
If you want to get it wrong, put an AM. But if you want it right,
Justin will mark it wrong.
military time. So, okay. Any questions? Now that we've got some dramatic stories and some over-the-top acting.
332 of them.
We good?
Great.
Yeah.
Okay. You guys are free to go. You guys have a good one. We'll see you next week. Make sure you stay on top of things with the syllabus.